It is frequent that you will be asked to either describe the acid-base properties of the period 3 oxides or to write some reactions of period 3 oxides with water to explain how they form acids or bases. So first of all, I highlighted the period 3 elements. In terms of what their oxides are, you can predict what their oxides are in most cases because you know their charge. So sodium oxide is Na2O because oxygen is a -2. Magnesium oxide, +2 and a -2 forms MgO. Aluminum oxide is a +3 and a -2. Silicone oxide is actually silicone dioxide. This is a case where silicone's pretty much adopting the +4 and we get SiO2. For the phosphorus, there are two possibilities that are commonly asked, P4O10 and P4O6. For sulfur's combination with oxygen, SO2 or SO3 are common. For chlorines, you may have Cl2O7, you may have Cl2O. I don't have a great way for you to memorize these or to rederive them, probably best to memorize them. There's no argon oxide because argon being a noble gas isn't going to combine with oxygen. In terms of whether they are acidic or basic or amphoteric, in terms of whether they're acidic or basic or amphoteric, we're going to approach it this way. So for the metal oxides, these two anyway, when they react with water, they're going to form an acid. So we say these are, they're going to form a base. They're alkali metals, alkaline earth metals, both of those terms mean basic. So they're going to form a base when they react with water. These ones are going to form an acid when they react with water. So we say they are acidic oxides. SiO2, however, should get an asterisk because SiO2 is usually in the form of quartz, which doesn't do much of anything when you put it into water. So it might behave as an acid when it reacts with other things, but not so much going to do stuff in water. Aluminum oxide, however, is what we call amphoteric. Amphoteric means it can behave as an acid or a base, depending on context. We need to look at our reactions with water. For the first two, Na2O and MgO, when they react with water, so I'm going to write this as a metal hydroxide. Correction, I'm going to write this as a metal oxide plus water is going to form a metal hydroxide. This is a new type of reaction that you're learning. So for example, sodium oxide plus water is going to form sodium hydroxide. Sodium is a +1, hydroxide is a -1, they form NaOH. To balance this reaction, we need a 2. Okay, magnesium oxide plus water is going to form magnesium hydroxide. Mg is a +2, hydroxide's a -1, they will form MgOH2. And I believe that reaction is already balanced. You're not going to worry about the reaction of aluminum with water. Okay, so that's our first type, and that's to form a base. Hydroxides are bases. If we do reactions with water for the non-metal oxides, non-metal oxide plus water is going to form an acid. The acid that forms can be hard for you to predict, especially at this stage of your career. So for example, let's say I have P4O6. It's going to react with water, and it's going to give me some acid that has hydrogen, phosphorus, and oxygen in it. One of those common acids is H3PO4. Another common acid is H3PO3, phosphoric acid and phosphorus acid. IB has different names for it. Okay, to figure out which, what I'm gonna do is I'm gonna figure out what the oxidation state of phosphorus is in this compound. We did this in the very beginning of the year. I don't know the oxidation state of phosphorus, but I have 6 oxygens, each oxygen at a -2. And that's going to tell me 4x minus 12 equals 0, or x is a +3. Phosphorus has an oxidation state of +3 in that compound. So over here, if I figure out phosphorus's oxidation state in each one of these, I can tell you which acid will form. I'm going to look at the bottom one here as an example. 3 hydrogens, 1 unknown phosphorus, 3 oxygens adds to 0. Solving for x, x equals +3. So phosphorus retains its oxidation state. So this is the acid that forms. If instead we had P4O10, figuring out the oxidation state of phosphorus here, would be an oxidation state of +5. I need to figure out which acid that forms. Spoiler, it's H3PO4. I'll show you why. 3 hydrogens plus a phosphorus plus 4 oxygens adding to 0. In this case, the oxygen would be a +5. And the phosphorus would be a +5, and the phosphorus doesn't change oxidation state. The chlorine compounds are figured out similarly. So are the sulfur compounds. Let's look at SO2 and SO3. There is an easier trick for SO2 and SO3. Just straight up add them. My compound's gonna have 2 hydrogens, 1 sulfur, and 3 oxygens. And that's the acid that forms. If I want to verify the oxidation state, in here, sulfur would have an oxidation state of +4. Sulfur would have an oxidation state of +4. For the second reaction, straight up add them. They're going to form sulfuric acid, and sulfur has an oxidation state of +6 on each side. So you have choices in figuring out again what the acid is or in memorizing these reactions. Our last two, Cl2O7 plus water and ClO plus water. Cl2O7 plus water is going to form HClO4. And if I want to verify oxidation states, figure it out. In here it's a +7, in here it's a +7. This should say Cl2O plus water is going to form HClO. Chlorine has an oxidation state of +1 on each side. I didn't balance these reactions, but you're, I'm sure, capable of balancing the reactions.